All right, we're back. We are MAPD124 in the winter 2017 semester at Centennial. That's Advanced iOS Programming. And it's week 5, supposed to be week 6, part 1 of our broadcast. So I want to talk about a couple things administratively. Next week, we're supposed to have our midterm test. Now, it's based on the stuff we've done so far to date, which means like basic UI stuff that we've talked about, things that you would have done last semester is what you've been testing on. You're going to be testing on this semester. And also, I was going to have the data stuff on the exam. I'm not going to put it on, right? Because I'm just talking about it today. So it's like you're getting it today and then you're going to test it on it next week, right? And its integration is difficult, right? Now, remember, you have an assignment 2 that is due on the 20th. That's next week. That's before the exam, right? So assignment 2 is, creating that to-do app for yourself, which is kind of, it should be, again, my hello worlds are, what I've already done with you. Can I make a calculator? If I work on a platform and I can make a calculator, I can do it on any platform. Chances are. If I can do a to-do app on the platform, I can do it on any platform. I can do it anywhere. Like once I know how to do one, I can do one. I can do one in PHP. I can do one in Swift. I can do one whatever, right? So you think. I'm going to talk about the difficulties of doing it with iOS, right? It's a pain. There's a lot of pain involved when it comes to doing any kind of data persistence. But I got a few examples. For today, if I go to our Slack channel, I'm going to put on, on GitHub, I've put on some code examples that I'm going to reference. There's 3. There's Lesson 5 persistence, that's with Plist. There's SQLite, and there's core data. We're not going to cover core data. That's kind of out of scope for our course, right? Only because it's using an object relational mapper to do the database stuff, and it's quite complex. However, the code is there, and it's in your book, if you actually read the book, and I've corrected the code so it works. Every single project needed code correction. Even though the book was written in 2016, late 2016 it was published, because of Swift 3 and the changes that happened, it needed code correction. So I went and did all that to make it work. And so that's why it is the way it works. So I'm going to kind of give these links. So this is the first one, and this is for the plist. So GitHub link for plist persistence. Spell persistence properly. Persist. That's that one. And then the GitHub link for SQLite. We're going to cover that. That's a very popular, and it's actually SQLite 3 that they use. You've probably already got something similar from your Android class. You probably did SQLite 3 or SQLite, yeah? The original one last semester with Hacky, right?
And this semester as well.
Good. So this is something you should be able to see. You'll see how different it is with, well, there's going to be some similarities, I got to say. It's not much different. It's just that the syntax is a little funky, and we have to use C. That's why I'm talking about C, right? So that's that one. And then the GitHub link, which we're not going to cover today because there's no time for all this stuff, for core data. Again, this is in your book. If you really want to do core data for your assignment, you can certainly do that. I don't recommend it though. It's well, actually, you know what? It's just as hard as SQLite. So either one, depending which one you decide to go with, I'm totally fine with. I don't care which one you use, right? Any one of these is fine, so that you can do your little app, right? So any one of these things, just put them up on Slack so you can have them. I'm also going to review C and C++ concepts. So how do we make a C or C++? And the reason why I'm going to talk about this is because you can use Xcode for that, right? Xcode has actually got a really good C++ compiler, right? That's built in. And we sometimes use C++ to bolster or help to create helper or adapter programs, especially when it comes to things like any kind of graphics. A lot of times we use C++ with something like OpenGL with Metal. That's what it's called. iOS is Metal now. That's what they use to create graphics. So let's talk about that first before we get into the Swift, right? So has anyone ever done C or C++, like any at all? Some of you may have. Hopefully you have. Yes, yay. Is it easy? No, right? Huh? It's not Swift. It's something totally different. Swift is not easy either, but C++ is another level of not easy, right? Oh, it's sweet. It's not. Is it sweet? I don't know if it's sweet. I never want to see C++ again after all this work I've done in C++. Not because I don't like it. It's just, it's very rigorous. There's a rigor just like there is with Swift, right? And it's not forgiving. It's not like C# or like, anything else. We're going to make a new project here. Let's do it together. We're going to make a new C++ project today. Something different. So if you notice, there's iOS, right? And nothing's in here for iOS. There's watchOS. We don't want to do that. tvOS. We want to make some stuff for the Apple TV. macOS. Here we are. And if you look, there's a command line tool. That's one thing we can make. Cocoa framework, a Cocoa application, right? And there's something called cross-platform, right, where you can use a sprite kit and so on. So if you think just to think about what this is, and if you're going to look at what application types you can decide on, if I go with Mac OS, and if I go with a Cocoa app, right, or if I go with a command line tool, either one, you have a choice of what to do. Let's click command line tool and click next. All right, notice that the language, you can use Swift, right? You can use Objective-C, you can use C++, and you can use C, right? For us, just because I want to make your life even more difficult, let's use C++, right? Now we're going to call this, no, you guys are crazy. You think I'm crazy, right? That's what it is, right? We have to make it more challenging. MAPD124, and we'll say lesson 5. We'll call this, because we have a bunch of lesson 5s. So yeah, winter 2017. I pull this properly, right? And we're going to say C. So we know what that is. So we know that's C++, or we'll say CPP. There we go. You know that's C++ when I go CPP, right? I'm leaving all this other organization identifier stuff alone, clicking next. All right, it's going to ask me where to put this thing, and I'm going to put it in my regular projects. Now, it's asking me if I want to create a Git repository. Absolutely, I do, because I'm going to share this Git repository. And here we go. All right, so I've got my main CPP, right? Now, this looks like, if you haven't seen this before, you can see that I've got IO stream as an example, right? And you notice that it uses C++ is a very, I would say, a lower level language than Swift, right? In my main, it's my main function, right? That's what it looks like. And what I have here is the standard library, right? Here's my standard library, right? And what I can do is I do something called a cout. It's not a count, it's a cout, right? It means, and I have these little things right here. By the way, you can also write this hello world like this. And of course, you want to use a standard library, so you want to do standard. And each function you do, you have to kind of indicate the library. Now, if you're using something like Visual C++ on the Microsoft side, you could put in a using statement where the namespace, as an example, would be standard, right? Which you can do. And if you did that, then you can get rid of this part, because that means that the standard library has been included. Yay, fantastic. You think that's going to help us, but really. So it's very low level. So what I want you to think about these little angle brackets, what they mean. Anyone remember what these, if you're ticked C++ or if you did anything like this before, what do these angle brackets mean? Anyone remember? What? What do they mean? Redirection, okay. You know, whenever I see these angle brackets, for me, being an old programmer, it means I want to move bits. That's what I want to do. I want to redirect the stream, right? And the stream here that I have is a character stream, right? Because an array of characters in C++ is exactly that. It's an array of characters. That's what we call a string. Notice here you've got a character pointer. Star means pointer, right? It's very interesting the way they do things. Here's hello world, and hello world, think about this string of characters, stream of characters, right, is being moved to, it's almost like in this direction, to the left, into the outstream. That's what's happening. It's kind of I'm pushing it into the stream that goes out to the console. And that's what it means, console out, C out, right? And L, end line, is like the \n character, right? That's what it is. And return 0 means null, right? So this is old C style language. I want to make a person class for a second, just like we did last time with Swift, to remind you. So normally when we make a class, right, can we write it inline? Should we write it inline in C++? Probably not, right? I want to write a new file, right? If I go new file, it's going to pull up which one of these I want to use. Notice I can go C++ file, right? Here's a C++ file. I could make a header file, which is probably what I want to do. When I make a class in C++, I want to have two files, right? I want to have a header file, typically, where I do my declarations. And then I want to have my C++ file where I actually write my class, okay? Just a review of what this looks like, so you can know how crazy this is. So let's write our header file first. Our header file is like almost like an agreement. The declarations all go inside there. So next, we're going to call this the person header file. So we've done this before, right? Person, create. It's going to go in the person.h. Notice that it's defining person.h, right? Now, if it's not defined, should I put it in here? Yeah. I'm going to define a class, which I'm going to call person. Okay. Here's my class. I want to have a public area for my class with some public functions, right? And so on. And if I know what I want, I can always do the same thing. I could do something like I want to include. Remember, the includes are things, libraries I'm including. I want to include what? Maybe a string library, standard string library. Maybe I want to include other libraries like some kind of IO stream or stdio, stdlib, a bunch of other things like that, right? For now, string is okay. Right? And what I want to do here inside my public is I want to declare a couple of variables. One of them is going to be my name of type string, right? And another one is going to be an int. How come my string didn't come up? How come? How come it didn't work, right? Int of type of age. We did this before, right? This whole example, right? So this is my string, and it's not giving me any errors, right? Which looks good, right? So I've got these two things. This is it. This is my header. What about my my constructor? I need those too, right? I need a constructor and a destructor. Typically, is what we put in there, right? So I put a constructor, right? And I put a destructor. There we go. Destructor and constructor. So that's our header. And let's add another file. Let's add our CPP file now. So I'm going to add new file. And inside here, I want to go and do my C++ file. Next. And see it says also create a header. We already have that. I'm not going to do that. I could have done that. But I'm going to say person, right? Person. Next. So my class here, create. Here's my C++ class, right? Now, what do I want to do here? I want to include my header, right? I can't just go here and just standard IO, right? I want to also include my header file, right? Which is my person.h. And then we should put it in quotations, yeah? Is that correct? Now I want to kind of indicate my person. I want to have my person constructor, right? So this is the constructor. Let's review. If you guys have done this before, great. If you haven't done this, don't worry about it. And here's my destructor. So again, it's from the person class. That's what this means. And I want to do this one, right? Those are the two constructors. So far it's empty, right? And if you look at the person.h, I also have age, and name, right? These public variables. Meh, not really happy with those, right? For now, but leave them alone, right? Just make it easy. All right, so in my person, I got my empty constructor. Let's make another one. So here's my empty constructor. This is my empty constructor. I want to make another one, you know, because we can do this in C, C++, same thing. Making a constructor, but this constructor, we haven't declared this one. We're going to declare it in a second. This constructor is going to take two things, right? A string name and an int age. We've done this before, right? Oops. What I want to do, first of all, why is it giving me the error? Because it doesn't exist. This declaration doesn't exist in the .h file, right? Which we got to do it. So in the .h file, these are just our declarations, right? I can declare another constructor, right? That takes string name and int age. We can do that. Right? And then it should get rid of this error, right? Once we've done that. Now, why is it giving me this error? If I've done everything correctly, right? And I've got this saved, how come I'm getting this error? This one that says this, string name, what's the error? This is unknown type name string. Did you mean standard string? Yeah, because if we don't include standard, right? If I don't say something like using namespace, even in here, standard, then it won't detect this one. Also, maybe what you want to do is what we did before is want to include the string library. If you want to do any kind of string functions. Right now it's okay. All right, so what we want to say is something like this. If I wanted to say this name is equal to name, it's like we've done before, right? Self name is equal to name in Swift. How would we do it? What's the protocol? What do we put in there if I want to say, can I use the this keyword? Do you guys know? Do you guys remember? Anybody? How about the guys that are smart over here? No? You could use this, but you need to use an arrow function that says this name is equal to name. This is the syntax. And this arrow age is equal to age. And that would be the same effect. Okay. So here we're basically saying that the member variable name is equal to the local variable name that we get into our constructor, right? This is a constructor that takes name and age as parameters. Very simple. But this string is a C-style string. We're going to see this when we do this, our persistent stuff. So just a refresher on how this all works, right? Totally acceptable. You can totally write it in Xcode. Xcode is a great C++ editor, by the way, I have to say. And it'll make and build everything for you, which is nice. All right, one thing we have to have is some kind of method, right, to do something, like maybe say hello, right? Like a person say hello, right? So I'm going to go back to our person class. And again, notice that we have to do the same thing here. And we could have, if we included the namespace in here, using namespace std, right? And it would kind of take away that issue, right? Same error we got everywhere else. Okay. Let's add another public method called says hello, right? And it's going to return void, right? Now I have to put the return type here because it's not a constructor. These are the constructors, right? Here's the destructor. These are just declarations, right? And then these are public methods. Here. So public methods need to have a return type, right? You need to put that in, specified void. Okay. Now this is the form. And if you've never seen this before, fantastic. You're seeing something new, right? If you've seen it before, don't worry. It's just a review for you before we get into Swift. Okay. Going back to person CPP for a second. As we switch over, now I have the ability. Now look, I don't have to put in, even though I've declared this says hello function. If I wanted to run this right now, right, it's going to build. Right, here's hello world, right? Because the main program right here, main program doesn't do anything. It doesn't actually, you know, kind of declare a person of type person anywhere, right? All it does is say hello. So this is what it does. So it builds everything correctly and links everything, any kind of header files, whatever we want. We don't have to put them here. We can also include them inside of a group, right? So if I want to, I can make a new folder, a new group, right? So I can call this includes, and then I can group this off. This doesn't do anything to the so I can put this in here, right? Or you can put this, you can call this headers, whatever you want to call this, right? Oops. How about we open this up and put this in there? Go in there. There we go. So so my person looks like it's in there, but actually, when we look at on the operating system side, you won't see a change here. Like if I run it again, it's not going to change anything, right? I'm not linking to something else. It's still physically here, but I can group all the includes together, right? So I can see only my main file, my CPP files here. And if you really want to be a stickler, you can probably put something like a new group from an organization perspective, and we call it source, or SRC, very common, right? And you can put these two in there. So kind of inside that group, right? So in our source files, we have our main CPP and our person CPP. And inside here in our includes, we have our person.h, right? But even though we declared in our person.h this says hello method, we haven't defined it. And we declare it here and define it here, right? So let's do that. So again, we have to say something like this. Void, then person, and then we're going to say says hello, right? You can see how it finds it here, right? And it says hello, we're going to just do a cout. So we're going to say cout, we're going to say hello, but I want to include, you know, plus this, and I don't have to do this, but I can do it this way, this dot name, right? Hello, whoever your name is, and then do an end. Very simple application. Now, cout, using a standard library. How come this doesn't work, right? It gives you the answer. Use declared identified cout. Did you mean count? No. Undeclared identifier. Oh, cout. How come cout doesn't work here in this context? Well, I do this, right? Will it work now? And if you look at it, what it says, use undeclared identified end L, end line, same thing. It's almost like it wants me to put this in there. However, didn't I just put it up here that I said using namespace standard? No member named cout with namespace standard. How come? What do you mean? Of course there is. How come it's not working? C++, C++. So why are we, it worked here. If I go back to my main C++, right? Worked here, cout, and I did this using namespace standard, right? Now we also included IOStream, right? And we got to make sure that our person CPP has that in there. It's not here, but also our person.h, one of them has to have it, right? Hopefully that'll be a nice fix for us, right? Right? Or else we won't be able to do that. Now we don't have to do that anymore. All right, so again, we're hello, whoever's name is, whatever. Now, how do I use this class? By the way, anyone not understand what I'm doing, please put up your hand. It's not going to get any easier today, right, as we do this stuff. I'm just creating a very simple class, the person class, right? All right, my main CPP, I want to create this thing, right? This person, I don't want to do this anymore, right? This last line, hello world. I want to say hello so-and-so, right? So how to declare it? I have to make a class the name, right? So first of all, I have to say something like, for me to use it, I have to include it. So include, now what would I include? Would it be the header? Well, yeah, right? So it's going to be the header file, which is going to be person.h, right? There it is. There's person.h. Now with that header file, I could go up here and say something like this, person, right? See how it gives me all kinds of code hinting right away. And we can say something like Tom, right, is equal to, actually, if I just do this in C++, is that enough? So I have to use a new keyword. Not exactly. Let me show you a couple of things here that's interesting. So if I go tom.says hello, and if I kind of put in, remember, says hello has two options, right? Well, how come the other one doesn't come up? How come I don't get the says hello option, right? With my constructor. If I just go says hello, what am I going to get? Do I have a name? Do I have any kind of default for name? That's going to be bad, right? So before I finish writing this, I may want to go back to my C++ class and say, well, you know what? I want to have some kind of default, and I can, if I don't have it, for example, in here, what if I want to set some defaults up? So this name, right, is equal to something like unknown, hello unknown, right? And this age, I should declare them as something, right? And I'll make them 0. He's 0, right? There we go. So now if I go back to main, and if I do something like tom.sayshello, right? Oops. Then one of my expectations is it'll say hello unknown. That's what I'm going to see because I haven't declared what Tom is. Right? Hello unknown. Right? Because hello, by the way. And if you notice in the person class, I've got 2 constructors, one that takes some parameters, and one that's the empty constructor, which is right here, that I'm assigning a default value. Unknown. That'll be okay. All right. So that's the, I didn't notice it over here when I did it. Basics, right? Basics. If you've never done C++, this is what it looks like. It's a funky looking language. C is not much better, right? It's pretty basic like this. In fact, C is even worse. C++ is better, I would say. Objective-C, very similar to this kind of stuff, and pretty ugly. This is unforgiving, just like it's unforgiving, if not more so than Swift, right? Okay, going back to main. How about if I want to use notice I didn't use the new keyword or any kind of new keyword, just like Swift. Swift, remember, we don't have to use new keyword in Swift, right? But what if I want to do something like this? If I say Tom, then is equal to person. Can I do this? And it seems that I might be able to do this. I could probably declare one of the options. Now, if I kind of type it in, you can see that there's 2 different constructors, right? I can choose the empty constructor, or I can choose this constructor now, right? And if I do, it gives me some defaults. So I could say something like Tom, with my name, and age. I can put a literal here as well. I'm 25 today, because I feel like it, right? And if I was to do that, not 25, but if I was to do that and run it now, you're going to see how hello Tom comes up, as opposed to the empty constructor that brings up hello unknown, right? 2 different constructions. It's an overloaded constructor, which exists in most modern languages. Where it gets funky, where C gets really funky is with pointers, right? Example is if I wanted to make use of the new keyword, right? Once I say new, now I can't do this anymore. In C, I got to declare Tom as a pointer. And once I do that, I can't use the dot function anymore. I've got to use the arrow function. And that's the only difference at the very get-go. Now, it'll compile, but Tom itself is a reference to a new object, a new anonymous object of type person called, that we're passing information into. And that's why we use the new keyword. We use the new keyword actually creates a new reference, right, to this anonymous object person. Different way of thinking, right? So now I'm actually using the pointer syntax. So Tom points to says hello, because says hello is a method that belongs to the anonymous person class that I've defined over here. Okay, let's run this baby, right? See what happens. Build succeeded, and you can see that it works. Right? That's all I'm going to do today with C++. Okay, I'm not doing more, right? I've introduced this because I want you to understand that there is another syntax involved. And C++ has pointers, and so does C. Pointers are references. It's a way of us referring to different objects. One more thing I should probably do is this. If I wanted to refer to Tom or use some kind of other structure, like for example, let's suppose I wanted to have an array of people, right? Okay, now we're getting funky, right? So let's just go back to the other syntax just for a second, right? Where I don't use the new keyword, By the way, it won't allow me to use the pointer syntax anymore. I'm going to go back to dot accessor syntax, right? Let's suppose I want to have an array of people, right? Okay, let's make that array. So it'll be an array that looks like this. It's a person array. I'm going to call it people, right? That's the array syntax. And I can declare how many people I want. A fixed number of people, let's say 3, right? And if I have 3 people, right, in my people array, notice if I kind of go here, it says unused variable people because I haven't used it, right? I can load the array in a number of ways with a for loop, right? Now, right now we only have one, Tom, but I'm going to get rid of it for a second, right? And I can do it like that. I can do it simple like this. I can say people 0, the first person, right? I can do is equal to, I can do new, or I can use person, and I can go Tom. My age is 25 again. I like that age. It's a good age. And I can also load the other ones, right? With my initialization, I could say something like this. I could say an integer of count, where counts is less than a certain number, right? Let's say, for example, 3, and then I can increment here, just like we do in other languages, count plus plus. All right, and then we have some statements in here. Very simple loop, and we can say something like people counts. It's going to start like here, and we'll erase this for a second. But we can kind of say that for each person, I can make a person of unknown. So I can initialize all the people in here with something, right? Actually, if I go people count, right, is equal to of type of person, right, where the name is unknown, right, and my age is something else, right, and it'll initialize 3 people of unknown origin. They don't know who they are. They're all 100 years old, right? And it works. You can see that there's no error here, right? But then I can simply do something like this. Then I can go people 0, the first person, is equal to, and then I can say the name of that person, right, is Tom, right? I can refer to that this way as well. Array syntax, right? And then I can say something like people 0, and it says hello, right? And it'll give me the exact same thing. I've got 3 people, but I'm only carrying with the first one, right? Or the zeroth one, because we're using zero-based counting, just like in other languages. And if I run this thing, we should get the same results, right? Nothing fancy here, right? I've got a couple people that are useless here. We got a bit of a memory leak because we've got 2 people in here that we don't care about, right? And they're kind of unknowns. But here we got 1 person that says Tom. But Tom's 100 in this scenario, unless I actually physically say that he's not. People 0, and then we'll say age, right, is equal to 25 again. There we go. Now it's normal age again. An age of a young person, which Tom in real life is not, right? Questions around C++'s syntax or anything weird that you've never seen before. This should all be review. If you've done C# or Java, it's very similar. In fact, you got to say that C is the granddaddy of all languages, right? Let's just think about what it is. And C++ is his younger son or grandson. It would be more of a grandson, right? Because there's other languages, other variations, right? And then, we have close cousins. We have Java and C#. There's some cousins of C, right? But they're definitely not as complex as the grandson C++. I'm saying grandson because there's been different versions of C++ in the past. C++, the earliest version was, I'll say it, the son of C, right? It's like the son of Superman, right? Still not quite fully formed. And then they came up with C++ 11 and C++ 14, which is where they came out these other versions of it until its current form. Still quite a low-level language used in game programming and other graphics, but as well as optimizing our code. There's nothing to say that we can't use in our regular code with Swift, C++. We can totally do that. And we're going to talk about an integration today when it comes to persistence, data persistence. It won't be C++, but it could be if you really want it. Okay, yeah.
Should we do the for loop for that one, or we can, for example, directly assign it?
Yes, of course, you can do it like this, right? You can also make it so that each of the people, you can people 0 like this. We don't have to even do this, right? I mean, I could also make this a reference by using a pointer, right? But for now, let's keep it simple. Like you don't even need this thing at all, right? I'm saying you could initialize this way, but you could do it this way too, without the for loop, right? This would run just fine. Because I don't care, right? But if I want to reference a bunch of elements in here, I could make all the elements kind of initialized, and then from there, especially if I had the same object. Let's suppose I had an alien. We're making a video game, and then I had an alien that I defined. I could create the alien, an array of aliens, just like I'm doing an array of people, right? And once I, declare the array of aliens, I could add the aliens into the application. Each of the aliens would have its own parameters and properties. There would be individual objects. Same thing. But the idea that I want you to take from this is C++ is complex. C++ and C uses declaration files, right? A lot of times before we declare a class or any other object. Remember that C itself just is not class-based at all, right? It's not an object-oriented language. It is a very low-level language. We're just going one step higher with C++, which is a little bit more useful today. And you could incorporate either C or C++ into your Swift code, with your Swift code, which is what we're going to do now. I've got some. Oh, by the way, I probably should put this up on GitHub, huh? Just so if you care about it, you can look at it. Source control. I'm going to make a commit. I've done these extra things. I'll say created a simple person class for demo purposes. Commit. And then one thing I do need when it comes to source control is I want to push, but I don't have any remote, right? See, there's no remotes available. I've got to declare my remotes. I got to create my remotes, right? So I'm going to go here, and I want to create a configuration where I click my remotes and add a remote. And then here it's going to be called origin. And what I need to do with my remote is, and this is what I'm asking for you to do, is when I create a new repository, making sure it's in the right place, MAPD124, winter 2017, lesson 5, same name, CPP, repository. I grab this, and this is the name of the repository. Go back to, not there, go back to here and punch it in there, add the remote. There's our remote. And then from here, this is all stuff we've already done. And then I can just push. And that'll push it to the remote. Right? Oh, yeah. Got to sign in for the first time. All done. And when I go back up on GitHub, you can see that you've got my little applications. If you would want to download this and check it out, if you couldn't do this or I was too fast, I'm never slow, right? You can go up and grab this thing and check it out. And by the way, if I wanted to add a Readme file, right, to this whole thing, I could say something like, make this a demo. Say lesson 5, C++ demo. And we'll commit new file. Great, but now we're behind by 1, right? Because I've got 3 commits, but locally I have only 2 commits down here. So I got to go to source control and pull. And that'll pull from the master branch, and then I'm good to go. Now I'm up to date. If you want to see what that looks like in Finder, you can see what it looks like. Notice that I have my Readme file outside. And inside, notice how the structure over here looks. but inside it looks just like this. I've got some metadata that gives me this source group, and this includes group, but inside this, it just looks like this. If I had these in different folders, it'd be totally different over here, right? But I could include it this way. Again, any questions around this? All right, let's open up our PowerPoint because I want to talk about some concepts around what we're going to be talking about from persistence today, right? So I want to go to our file. And again, I've created this PDF. It's PDF for you, right? But really, it's about persistence. And there are 4 ways to do it, right? There's a way that they talk about in the book with object archives, right? There's another way with property lists, right? There's 2 other ways, SQLite 3, which we're going to talk about today as well, and core data, which is, now this is, they say persistence tool, but I also want you to think about core data as an object relational mapper. And if you know what that is, if you're database, if you've ever done database before, it's like using ASP.NET's entity framework, right? It's an object relational mapper that helps us do SQL even easier, right? As opposed to using SQL statements. That's what it does. Okay. So a lot of times what we want to be able to do is get access to the documents folder. And all of our applications, whenever we have an application, we have an actual documents folder that is inside of our app. That's what we have. Now, we don't have access to that directly. And if you actually plug in your app, your phone, and try and get access to the documents folder, it's going to be negative. You're not going to have access. It's sealed, right? You can't have, the one thing that iOS does not allow you to do, you have direct access, like to actually see what it looks like on the document side. So again, in earlier versions, we're able to see it, but now in the latest versions, especially now, we were not able to see that. We do, however, have access to the documents folder on our system, and you can do that by looking at the Finder window and going into our library folder, right? And that's where we can hold a lot of our documents, especially when you have a device. So if I have a simulator like this, let's bring up one of these. The first one I'm going to look at is persistence, right? So if you want to download persistence, again, please go to the GitHub repo. Please don't try and put this together on your own. I'll tell you right now, it's like a pain to put it all together. We'll talk about how to do it, right? But what I'd like you to do is try and go in there and grab it. So for me, I'm going to open up a project that already exists, right? It's not here, obviously, but it's going to be inside my courses, inside Centennial and MAPD. That's really loud. Here and inside my core archive, I have something called persistence, and I'm going to open up this Xcode project, and we're good to go, right? And we'll talk about it in a second. We'll talk about the structure of this project in 1 second. But one thing is, if I run this project in a second, I'm going to run this thing. What it's going to look like when we build it together is something we almost did last time, which is when it comes up, running the simulator, which I'll run for sure at a scale that's much lower. I have some stuff that I put in. Line 1 is Tom 2. Notice I picked up the stuff that I had in there when I was building this project, right? This is using persistence. So between loads of my device, I'm able to pick up information, right? And I'm not using a SQLite or core data here. I'm just using the plist. That's one of the ways we're going to do it. Properties list method, archival. So here, if you notice, we've got our device. Now, normally our simulator, if you notice what simulator I'm using iPhone 6 simulator. Well, this is being stored somewhere, and if you want to see where it's being stored on your phone, on your operating system, you have to make or have access to the library folder, right, on your device, on your machine. So if you're someone who owns your own Mac, and if you have access to your folders or your home directory, mine is Thomas, right? And if you scroll down, you can see that I have my library folder, right? If you don't have access to this, by the way, and again, on the PowerPoint, it tells you how to get it. It says open Finder, navigate to your home directory. And if you can see your library folder, that's great. If not, hold down the Option key and select to go library. So if we were going to show you that, so if I go to this, so my Finder window, and if I go to Options key, right, if I go, then I should be able to go to my library, right? Now notice, do you see that here? Look, here's my Option key being pressed. See that? And if I go to Home, it's not like it's going to show me anything. I mean, it's showing me my home folder, right? But notice that there is no. If I go to Folder, and if I want to look at Library, it's showing me this folder, but I could put in there the library folder, whatever I want. Now, why are we in here? Because in here is where we're going to get what it looks like inside of our device, right? Where we store everything, right? Okay. So where it's going to look like is, again, the library folder, we're going to drill down to Developer Core Simulator Devices. Let's go back there. So Developer, hey, where is it? Here it is. Core Simulator Devices. And now you're going to see a mess. Oh my God. What are these hash, symbols? What are they? Well, they represent each of my devices, right? All of my simulators that I've ever used, right? You might have some less, but here's an example of my device right here, this device. If I scroll down, right, somewhere in here, it's going to show me my folder, my documents folder. Here's my documents folder, right? So inside of here, again, this is looking at this first one. Notice it says today. This is how I know it's this. My data, my containers. So again, you'll see a subdirectory of the simulator in your Xcode installation. And then all these UIDs. We want to look for a file called device plist, right? So just inside here, there's got to be a file that says device plist. See if you can spot it within all these files. Here it is. Right, and I want to open this up. I don't have to open it with Xcode. I can open it up with a notepad or something like that, right? Or some kind of text wrangler application, right? And notice what it says. It tells me this is my device, right? Here's my device type. Here's the simulator, and here's my iPhone 6 simulator, right? And if I look over at my Xcode right now, I'm using the iPhone 6 simulator, right? So that's a good example of where everything is, because we're simulating. We're not really doing a real device. I can never look at this data on the device. It wouldn't allow me, right? But I can look at this thing inside of my operating system. And the operating system is interesting how they store everything. All the builds that I have for each of my applications are right in here, right? Now, these are all open. You can see that there's a lot of empty stuff going on. But there's going to be my application. I want to find my application. This might be a little bit tricky, right? But if I go through, I love when it does that. And if I go through and look at my application to find my application, because these are all my applications right now, right? There's one of them, right, that has information that I want to get to. There's documents. Notice that you have to drill down to find the information. These are all the apps that are pre-installed on the simulator, right? And other ones. Anything that I install on the simulator are going to be right here, right? I'm just going to kind of close those down. Okay, let's take a look at this. So if I go to here's my library, my documents. I can see my preferences. If I kind of pull this up, it says mobile for Safari. What's this? A Safari app, right? That's what this thing is, right? And you can actually look at each of the apps and the way each app is structured inside of your device, right? Again, if it exists, these ones are empty, but you can see that if I go down to each one of these to find them, I could find information for all of these ones. These are all empty. But the ones I'm really interested in are the ones that have access today, right? That's a good indicator of if I've got anything in there. And I've got this app, right? Here's my simulator, right, that I'm running. If I press Command H, right? Right? Not Command H. Where is it? Shift Command H. That's what I meant. I've got a bunch of them. These are the three that I have, right? So here's persistence, here's core data, and here's SQLite. Those are the three apps that I have on my simulator right now, right? If I wanted to find them, I could, and I got to search through here to do that. Try it. Please run anything in the simulator, and take a look at your operating system and see if you can find your library and the stuff that where everything's being stored, because we want to take a look, we want to inspect what's in here, please, right? And the other question I have is this really the simulator that I'm using, or is this another version for another iOS version? Remember, because I have iPhone for iOS 10, right? Is there another one for iOS 10.1? Yeah, there is, right? So I might have two. Maybe I'm looking at the wrong one. And how do I know? Well, it says 731 today. Maybe that's the one. How do I find it quicker? Is there a way that I could find, what do you recommend? Like, you know, I can go through each one of these and look at documents, because the top one clearly shows under documents or under library some information. There's obviously some information that I got from it last time, right? In my content. So how do I find the one that I want to find? Right? The one that has all the information for my app. Is there a quick way? Oh, single view core data, right? So that's kind of a hint of how to do that. And there's also .SQLite. That's interesting, right? So this is my core data app right here. Okay, that's a nice one. Here's my library caches, snapshots, right? So single view core data, if I look for that, and by the way, if I click here and search, will it find it in here only? Hell no, it's going to find it under this Mac. That's not what you want at all. So this is where you want to look. Single view core data. So under documents, nothing underneath there. Let's see if you guys can find it. Remember, so it looks like this. Containers, data, application, library, caches, snapshots, right? Right, caches. So even under preferences and documents, right? It has all kinds of information. The documents is a good indicator, because if you have anything under documents, chances are you're going to see your app. Oh, there's one. There's Plist. This is the one that I'm looking at right now. Right? This one. And notice there's the plist. This is a preference list or an archive of my data. And if I look at the plist, open it up. So let's open it up with Text Wrangler. Right? So open with, again, Text Wrangler is just an app. You can see what I'm storing here, right? So class, and then this object. Oh boy, once we start putting NS, you know it's using next step. That's what it sounds like. That's where it comes from. NS is next step. Remember, next step was the old Steve Jobs company. I don't know if you guys know that. You guys know that? Some people do. Did someone not know that? You didn't know that? Oh, I gotta talk about this today too. No problem. Next step, right? And we'll say Steve Jobs. So Next, it was a computer company, Next Software, that was owned by Steve Jobs, right? And it was between the time when between the time when the oceans drank Atlantis, but no, it wasn't that far ago, right? It was back in the day when Apple had fired Steve Jobs, right? And what he did was he created his own company called Next, right? And he licensed software, Next Software. And what happened was he actually created the original software for the Mac when it came back into, or actually it was called the Macintosh back then, Macintosh computers. There was two divisions. There was Macintosh and there was the Lisa division, right? And he created the He basically said Lisa division is pretty much dead. We're not going to do that anymore. We're going to use the Macintosh, pretty roughly too, from what I understand. And then Lisa was gone, and sure enough, they created Mac. And they took a lot of the code, and every time they made it was based off of C, basically old C code. And what they did was they created everything they did from that point on. Anything that has NS in front of it comes from next step, because they used something called Objective-C was a mishmash of Smalltalk and C, right? That's where it came from. So anytime you see NS in anything, any kind of type that you see in Swift, it comes from next step. That's where it comes from. Let's go back. Sorry, I know that's a little lesson in stuff, but in the history. So again, go look at this. And in our code, we have an NS array. Once we see an NS array, that is an Objective-C type array, right? NS string, C style string, all right? Anything like that is, when you see an NS in your code, you know it comes from next step, right? Go back to the operating system for a second. So if I look at my text wrangler, you can see that it uses NS objects. And look, here's where my data is being stored. Tom, hello, goodbye, tomorrow, right? If I was to change this data here inside my plist, right? So let's say, for example, I don't know, I'll say something else. I'll say, instead of hello, goodbye, we'll say Conan, right? The barbarian. This would be like weird. Conan the barbarian, save. It's Conan the barbarian, goodbye, tomorrow. So we see that something's really different there, right? And if I go back into my simulator and run persistence, right? Well, it shows hello, goodbye, whatever, right? Okay. Now, how come? I mean, I saved it. So I went physically here and saved it. What happened? Well, let's run this thing again and see if it. First of all, I'm going to stop everything, right? And let's run it again and see what it says, right? Does it pick up my Conan the Barbarian? And it did, right? So you can see how the data is being stored. The data is being stored physically inside of something called a plist. This is the easiest way of storing data onto the device. It does not have any kind of security whatsoever, right? And for our application that I'm asking you to build for next week, this is okay. If you really want to make this work, I'm okay with it. You're just storing data. All you're doing is storing some simple to-do list. It's okay. Challenge. If you want to use SQLite, which I'm going to talk about today, I'll give you a bonus if you can make it work. If you want to use core data, I'll give you a bonus, right? And if you really want to use something else, you want to use Firebase, I'll give you a bonus, which you guys know from last semester, I mean. So anything like that. But this would be the simplest and easiest way to create stuff. And I'm going to give you the code right now. So that's where it is. I wanted to show you this because some of you may not know how everything works from a simulator perspective. It's actually physically here. So you can modify the actual the stuff that's in here. You can see that I'm modifying stuff. And also notice that when I look at the type is an NS array. That's exactly what I have here, plus a bunch of other things that it stores here about things like your version and a bunch of other stuff. This is one place to look. But what if I don't want to look here, like so low level? I don't want to look at my device. Is there somewhere here that I can look to find it? I must be, right? If I click on the actual manifest, this is the manifest of your application, right? Just like it would be in, and I want to change this first of all. I want to go back to Centennial. Here's Centennial. And you can see that I've got all this stuff. My launch screen, what is it? Right, here's my launch screen. I launched my storyboard. And some of you guys did for your first assignment, you kind of went to your launch screen here. And you're like, Tom, yeah, we have a really cool launch screen. And you just put like a name in here. Right? Tom, look, we're really cool. We have a launch screen, right? And I want to put some kind of thing like a hello world, right? So you went down here, and or maybe you accepted the default one that comes with your single page application, which is even dumber, right? And then you went down here to your label, right? Or maybe you didn't. And you kind of drag and drop this label into the screen like this, into your launch screen. And then you kind of say something like, you know, hello world. Then you can add your constraints in there because it's just another screen, right? Right, here we go. Constraints for the launch screen, right? Nice and easy. And then shouldn't this launch? If I was to run it, if I was to stop this, shouldn't it say hello world and then take me into my application? Shouldn't it be like that? There it is, right? Hello world, and then it's gone. So again, notice if this is just my manifest, right? Which kind of details where I get everything, my app icon and so on. And here's my embedded binaries, right? All these things are here. But where is my info plist? Well, right here, right? I don't have to look at my manifest so far away. And my info plist basically does a couple of things. It's just a file where if you notice, it was an XML format, right? Let's go back to that text wrangler, right? And actually, did I close it down? I did. Let's take a look at this plist. Here's another one. So if I open this up, any plist at all, plist is just a preferences, right? A properties list. So if I go to my properties list, it's in XML. It even tells you XML version 1 encoding UTF-8, right? Doesn't matter whether you look at this one, this plist, or another one. It's a properties list. Okay. By the way, this is another hint on how to see your simulator, right? Because this plist, this device plist, is kind of the directory for all the other ones, right? So it tells you all of them, which one they are, what's the hash code for it. Okay. So if I wanted to find mine, and I knew mine was an iPhone 6, I theoretically could search, right? And I could search for iPhone 6. I knew how it was configured. iPhone. Next. Oh, there's iPhone 4, 5, 6. There we go. There's 6 and 6 Plus. I've got this one. And it tells you that this one here. Thank you. No, I don't know that person. And here, if you notice, it says simulator type is iPhone 6, but it doesn't tell me what iOS version. Well, here it is. Here's the iOS version. The key is 9.2. I don't want to use that. But if I scroll down, I might be able to find an iOS version of 10.x or whatever it is, wherever that is. There's 10.2, and there's my iPhone 6, right, which is the one I was using. And this 55DA3E, this one, is the one that I could search for in my files. Here, you see it? I mean, even though it was the first one. But if you ever want to, the one that I search for is this plist right here, which is inside of your devices folder, right? So that's where all the devices are listed. And if you notice, a plist, properties list, is just an XML file, right? So if that's the case, and again, I'm just showing you this stuff so you understand where everything is positioned, then shouldn't my data be available here? I'm looking at my plist, I'm clicking on it. I could show this in Finder as well. It's another really quick way of doing it. I can kind of show it in Finder. Show me my plist. Right, here it is. And this is my persistence app, right? And what does it show me? If I open with, again, text wrangler, does this give me the same information? That's a different plist. Look, that's not the plist that I'm looking for, right? My property list I'm looking for is hidden. It's inside my simulator, like yours would be if you're using an actual device, right? It's a properties list or an XML file. That's what I want you to think about, where you're storing all your data, right? And that's why not secure and not recommended for anything that's any app that you want to secure down or whatever, because if they download your app and someone disassembles it, they can get your data, right? So for us, it's okay. The real world, SQLite, or you want to go with something like, core data. But this basically tells you information about your app. That's what this info.plist does. So can I get it from here? No. How about capabilities, right? Capabilities tells me what I can use, what I can't use. Nothing I've touched in there. There's resource tags. There's info. Here's my info. My document types. Here's my iOS target properties. I can change all this here. This obviously looks like my plist, which is right here, right? My build settings. If I was running a C++ application, my build settings would tell me where I can find my include files. I can redirect things to how I link documents together. You don't want to touch this. If you're not good at setting up your application, this can be a very challenge. You can mess up your application right here. So please don't touch anything that's in your build settings, because this is automatic for us. Actually, you might think that Xcode is really lengthy and difficult to use, but if anything, it's including a lot of stuff in behind the scenes. You don't even know what's happening. Search paths, build phases, you can specify that. And if I go down the list, you can see that there's other things that you can go here. Here's my copy plist file. If I want to do the copy to target, and there's a bunch of different functions I can use here if I like. We're going to come back in here though. If I go back to general, notice that there's signings, right? There's deployment, and there's other things down here. We're going to come back here. Okay, so it's definitely not in there. So I can't get it from here. There's no way of getting from here. You need to go, like I said, into your document to get it. Let's take a short break. I think what we've done is we've covered C++, and you know, I don't know about you guys, but most people have like that whole, remember we talked about before, did I tell you guys how often we watch the videos? 8 to 10 minutes. Did I tell you that? No? I did a study on the videos, people that I make for this class and other classes, and the average time to watch is 8 to 10 minutes, which happens to be the average time we like lose our attention, right? After 8 to 10 minutes, you're totally bored, and you're like, you want to fast forward or put me on like squirrel time, right? And that's what we do, right? We don't want to watch the whole hour. You focus on the stuff that you need to get out of that hour, and then you leave, right? So I've gone way beyond the 8 to 10 minutes. Let's take like 10 minutes of break. We'll come back and we'll continue with how we set this up, how we set the application up. How is it going to work for you?